Hello everyone. Today's problem is build a matrix with conditions. Another grid problem. This time is hard. Apparently, Leetcode has a lot of fun placing hard problems on Sundays. So the problem of today, let's read it. Let's explain it really fast. So we have to output a matrix like yesterday's problem, but this time we have more complex conditions. For example, this matrix here will have two vectors associated, which are row conditions and call conditions. Row conditions, as you can, let's analyze this vector. We have 1, 2. This means that if we read the matrix from up, like top to bottom, we need to find a 1 and then a 2. So 1 must precede 2. In this case, and for example, 3 must precede 2 as well. So as you can see, this matrix satisfies these row conditions. Call conditions is similar, but we have to read the matrix from left to right. So 2 must precede 1, and 3 must precede 2. K is basically the number of different numbers that we can have in this matrix. So if K is equal to 3, it means that the matrix should contain numbers from 1 to 3. And yes, we have to output any matrix that satisfies these conditions. So let's copy this input here, as always, on our board. So what's the approach here? We can, like, the intuition here is to see these conditions here as a graph. So when we have complicated conditions, usually it's going to be a graph problem. So for example, 1, 2, we can see it as an edge going from 1 to 2. And 3, 2, similarly, it's something like this. So let's focus on row conditions for now. And what we can do is we can use topological sort to sort of convert this graph into sort of a ordered sequence of elements. And we want this ordered sequence to be such that if we sort of visit the nodes from left to right, we satisfy all of the conditions. For example, in this case, if we visit the 1, then we can visit the 2. So sort of like 1 precedes 2. And the same thing is with 3. So we have to visit 3 before being able to reach 2. So we can basically reach 2 only if we visited either 1 or 3. And this thing, when we apply topological sort, it will look something like this. So we have 1, 3, and 2 at the end, like this. So topological sort basically means we have to linearize our graph. Then we can do the same with the call conditions. So in this case, we have 2, 1. So we have 2 connected to 1, and we have 3 connected to 2. So when we topological sort this, we will have, for example, 3, then that points to 2, and 2 that points to 1. So in this case, if we want to visit 1, we have to start from 3, go to 2, and then go to 1. So these are our two vectors. So if we basically remove these connections here, now we don't care anymore about these. We are sure that if we visit the elements from left to right, we satisfy all of the conditions. So now the approach is similar to the one that we did yesterday. So we initialize a matrix with, in this case, for example, 3 to 1. So with the call conditions, so 3 to 1, and then all zeros. And now what we can do is, so this one is satisfied, because if we read the columns from left to right, this condition here is satisfied, because we have the 3, then the 2, then the 1. we just have to move the elements on the columns such that we also satisfy this condition here. So the 1 will be shifted of 0 position. So we start with this. 1 will be shifted down of 0 positions. The 3 must be shifted down of 1, and the 2 must be shifted down of 2 positions. The result matrix will be something like this. So we have 0, 3, 0, 0, 2, 1, 0, 0, and 0. Right? Yeah, I think that's fine. So as you can see, this one satisfies our conditions. So if we just copy this for a moment, just copy this here. So row condition is 1, 2. So 1 precedes 2 and 3 precedes 2. And the same thing happens with the columns. So 2, 1, 3, 2. So it's all fine. So this is a valid matrix, basically. It's actually not the same one, but it's similar to the one that we, yeah, basically he's like the Leetcode matrix just swaps the first and the second row, but it's the same. So this is the approach. The code is kind of complicated. In fact, I mean, it's not hard. You just have to know how to write topological sort. And the topological sort, once you write topological sort, then you just have your 2 vectors and you just do the thing that I said. So basically, as you can see here, I have my row order and call order, and I call topological sort to have my 2 vectors. And then once I have my 2 vectors, I just do exactly like what I explained before. What you can do is just go to Wikipedia, and it provides a pretty nice pseudocode for topological sort, and it's quite simple actually. So I don't think it's going to be a huge deal. I will probably publish a video on the implementation of topological sort sooner or later. So thank you everyone, and see you tomorrow probably.